Yeah, thank you, and hello, everybody. So while I don't want to talk too much about Martin and myself in the beginning, I think it's fair to say that we are both veterans of the ORT or OSS Review Toolkit ecosystem. So we've been there since the beginning, more than 8 years. And also for those of you who attended Emily's talk, 2 talks behind, basically, I would say the company we're working for, Double Open, is an open source company in Emily's very definition. So maybe for the fun of it, who's already familiar with what the OSS Review Toolkit is? Who has been tried it out or worked with it already? Okay, quite a few people in the audience, half maybe. So for those of you who are not aware about what the OSS Review Toolkit is, on a super high level, in a nutshell, it's a platform to automate software compliance checks. So it's not strictly limited to license compliance checks, although that's where it's coming from. It also extends to security compliance by now and other things. I think it's fair to say that it comes with best-in-class software composition analysis for the supported build systems. So we do some things quite differently than many of the other tools do in the market, both commercial and open source. So if you think about Dependabot or whatever. So it's at least my personal strong belief that these tools are not doing it right. And to some extent, we can also prove it. But that's not part of the story here for today. And then in general, we don't intend to be a strict competitor to many of the other tools, but more integrate with existing tools. So we have a very highly configurable and plugin-driven architecture with integrations and a lot of report formats that we can generate. And this picture on the bottom shows on a really high level, the idea is you put source code in, then the magic happens, and you get compliance documents out. You can imagine it's way more complicated than that, but that's the rough idea. Let's take a brief look at the history of ORT, the original OSS Review Toolkit, which is command line based, so you better understand the motivation for us to create the ORT server. So the project has been around since roughly 2017, where I, back then at a company called Here Technologies, which was somewhat a successor of Nokia, was creating a bunch of internal scripts to analyze the code bases written in various different programming languages in the company to fulfill license compliance checks. At the same time, we basically rebuilt the Here internal open source office, and we decided to develop everything fully in the open to begin with. So about 3 months later, we created the first public commit of a then unified project written in Kotlin, which was the original command line interface to ORT. Then some months later, the name OSS Review Toolkit was first mentioned of the README that we committed there. By 2019, wider adoption was received by companies like Bosch, for example, and also the scope grew from the original scope, like I mentioned, license compliance and then security compliance and other stuff like also general community health metrics. To further help the wider adoption, we at some point transferred the GitHub repository to a neutral organization, so it was not hosted anymore at the Here Maps umbrella, but in its own GitHub organization. And as further adoption grew, we switched from a rolling release model to Semver-based releases, because many of the commercial companies that were using our tooling to assist with their compliance processes, they wanted to have releases that they can refer to with version numbers and so on. Fast forward yet again 3 years later, today we did 153 releases. We received around 2,000 GitHub stars, which is not too much if you compare it to OpenClaw or things like that. But for a niche project like this, and for a project that is mostly used by proprietary commercial companies and not open source users, it's quite okay. And we managed to at least attract 122 contributors, which is not easy. Growing a community is not super easy. So in contrast, the ORT server then was basically created to make ORT easier to use, because originally it was a tool created by developers for developers to fulfill the requirements they were receiving from product owners or so on. And also, the ORT server first started as a company internal project at Bosch. It was actually my former team at Bosch sort of that started the project. And then it took quite a while to make a formal proposal to the Eclipse Foundation to create the AppSys project under which the ORT server is now hosted. And then yet a few months later, the first public code contribution was made in February 2024. And then only the UI development started. So until that point, there was sort of only the backend and the API. And then March 2025, there was the first 0.10 release. And again, fast forward to today, we have 77 releases, only 50 GitHub stars, right? So that's quite a different number, although the project is younger, of course, and 19 contributors. So if you feel like ORT is being a good project, please visit the GitHub page and leave us a star. That's always motivating us developers. So moving to a side-by-side comparison to give you a better understanding of what those two projects are and what the target audience is. So ORT, like I said, it was targeting mostly developers in the beginning. Of course, people started to pick it up and created fancy and sometimes crazy workflows around ORT in their own CI/CD systems. And it's working okay for most of the people who are very deeply into the ORT topic. But the ORT server is really meant to be used for everyone. So including, let's say, low-level developers up to whatever, project owners, project managers, people working in OSPOs, on policies, legal people, everyone. The interface, I've mentioned this multiple times, for ORT is the command line interface, and we follow paradigms like configuration as code. You write YAML files to configure ORT and stuff like that. And not everybody feels familiar or comfortable with writing YAML files. So the ORT server, it has a nice REST API or a web UI that talks to the REST API and makes it really more visual and convenient to use. Scaling has historically been a problem with ORT because of course you can call the ORT CLI in your whatever GitHub action nodes and scale that way somehow. But at the latest, when it comes to the process scaling, so how do you curate package metadata at scale? How do you review scanner false positives at scale and stuff like that? There are some boundaries, and we are trying to solve these in ORT server as well. On the technical side, scaling is done via Kubernetes, and the UI helps a lot with scaling the actual review work and implementing your processes. Then finally, something that ORT does not have at all. It's about access and user management. And on the ORT server side, it's sort of enterprise ready. We have OICD integration and user management via Keycloak. How does that help you now with fulfilling obligations from the Cyber Resilience Act, the CRA? So the idea is you can very briefly, again, on a high level, maybe separate CRA obligations and requirements or activities that you need to work on into those four phases. So note, by the way, this is not aiming to map things to a software development life cycle. It's a different view. It's more close to the original regulation, maybe. And there is a phase that we call initiation, and as part of that, you have a product definition. So everything that's written in pink on this page is something where we believe ORT server can help you to highly or even fully automate your applications. So the product definition is something that we can depict in ORT server in a hierarchy, because we have, as you will soon see in the demo given by Martin, organization, product, and repository levels, and you group repositories on the product level. That's your implicit product definition, sort of. For the risk assessment, that's mostly still human work that needs to be done and documented. That's not something we cover yet. But looking at the pre-launch activities, for example, development practices, that's something that we implicitly check when analyzing the code base for dependencies, because it will work best if you follow certain best practices for dependency management and maintaining your build system. So you implicitly get technical issues if you don't follow these best practices. Similar for vulnerability handling. So we have a lot of integrations in ORT that talk to vulnerability providers like Google OSV or About Code Vulnerable Code or what's their Sonatype OSS index and other stuff. Dependency management is somewhat related to the development practices. So if you already do proper dependency management with a dedicated package manager in use, then this will make, of course, your life much easier and the results better. And that's also something that we implicitly check for when doing software composition analysis with the ORT analyzer. And finally, SBOM generation is, of course, also built into ORT. So it's one of the many plugins we have for the reporter step. So we can generate SPDX SBOMs, CycloneDX SBOMs in whatever YAML, JSON, different schema formats. So you're covered there as well. Then when it comes to post-launch activities, you also need to regularly monitor your product for vulnerabilities, even if you don't have any code changes. It could be that vulnerabilities are only discovered after some time into the market. This is also something that we can help with scheduled jobs that will come at some point. So regularly creating analysis runs on the product, not triggered by code changes like pull requests or whatever. And also on the side of archiving the software that belongs to your product, we can assist with the source code bundle that we have and create archives for maintaining your code base and the dependencies for whatever years you need to keep them in order to build them also when open source projects disappear, maybe. Okay, finally it's demo time, so I'll hand over to Martin so you get a glimpse of the ORT Server UI.
Okay, thank you. Oh, mic is working. Okay, so I just walked you through the UI. So this was mainly built at Bosch, as you heard already. So as an internal tool, mainly to replace the Azure-based pipeline that we had for running ORT, because it just didn't keep up with the scalability requirements we had back then. So, and because of that, also the structure is a bit tailored around this use cases we had there, but we believe that works well for others as well. So the basic structure is that on the top level, you have organizations by which the whole content is structured. So for this case here, I created a FOSS backstage organization. And within one organization, you can group repositories, so code repositories, into different products. So for the example case, I made here one for Eclipse AppSys for the ORT Server project, one for the OSS Review Toolkit, and sample repositories, which is what I will use for the demo now. And so this is already one feature that you couldn't have with ORT. With ORT, you just got a lot of YAML output files, and you would have to manually collect the data somehow or group it. And with the server, you have here a complete overview of the organization. You can see a summary of all the vulnerabilities that were found during scans in this organization across all repositories, and the same for issues and rule violations and so on. So if I go now to this sample repository, so I used for this test a small Java library called Semver4J, so just a library to work with semantic versioning in Java, and used it just to have some small sets of sample data. So if I go into here and just show some runs, so you can see here, I first did a scan of the current main branch of that library. So you can see the revision down here. And it actually did not find any issues here. So you can see here a quick summary which shows the number of technical issues found, vulnerabilities found, and rule violations found. So that already shows, so from that perspective, everything is fine. But because I needed some problems for the demo, I scanned a pretty old version, version 5.0 from sometime in 2023. And here we could actually find 2 vulnerabilities. So I can now have a look at that. And I see that there were 2 vulnerabilities found for some test dependency of the project, so assert J core. And then basically, if there is a vulnerability found in a dependency, there's just a few things that could be done. The first thing should, of course, checking, is there a new version available which doesn't have the vulnerability anymore? But let's assume in this case, this is not possible. So then you could either just somehow try to get rid of the dependency, or you could try and check if this vulnerability does actually affect your code. And for that case, we show also all the vulnerability details here. So you have first that COSS radar, which shows a bit the severity of the vulnerability. We have the description and also a long list of all the references that we got related to that vulnerability. So we can do the research on your own. You could click on those links and check what is actually behind that in detail. You also have this here. If I collapse it again, you can see we have 2 vulnerabilities here, which are actually just coming from 2 different providers, because the whole thing is not a rewrite of ORT. That's all completely based on the ORT code. It's just a new way to run ORT. And of course, that means it also supports all ORT plugins. So in this case, for example, we have 2 advice providers that can retrieve vulnerabilities, and one is vulnerable code, and the other one is OSV. So both actually reported the same vulnerability here, but just with different identifiers. One had a CVE, the other one I think that's some GitHub ID, I don't even know. Okay, so as this is just, if you look at the description, this is just it even says here, an application is vulnerable only when it uses untrusted XML input. So let's assume we do not use those functions. If we do not want this vulnerability reported again in the next run, and we want to show that this is fine. So that's when I would create a resolution, and I would select a reason. In this case, for example, I could say that's ineffective here. And I could say, let's give some reason. Because later I would like to understand why it was marked as ineffective, of course, so you would have to give a proper reason here. Then I can create a resolution. And then it will show here already that this resolution will be effective in the next run when I do a rerun, because it's a pipeline-based approach. So in the next run, it would recognize that resolution and not report that vulnerability again. So because the run takes a few minutes and we don't want to wait here now for 5 minutes until the run finishes, I have already prepared a follow-up run where I did this already for the other one. So you see here that in this vulnerability, let me collapse it again quickly. I now have one which is marked as resolved and the other one is marked as unresolved. So if I would run again, this is the one I just resolved. This would also be marked as unresolved then. And then I would get a green light basically saying no critical vulnerabilities found in that project. So that's the part mainly about CRA-related vulnerability management. But I also want to show what else we got here. So I would just want to have a quick look at how do you start a run here. So there's the UI that was added actually a bit later to the project. Maybe you remember from the timeline that was started sometime in 2024, the UI development. In the beginning, that was mainly about automation via CI integration. So the whole purpose was that they have a REST API that you could easily trigger from a GitHub action, from Jenkins, from whatever environment you want to start a scan. You could select exactly what scans do you want to run. Do you need vulnerability information, license checks? And then you could get the result later on. And you will, if you look at this form to create a run, you have, of course, a way to enter the revision that you want to scan and some detailed configuration. For example, here we have labels for the distribution type, which influence what actual compliance rules will be applied in the end. So this is here for the open source compliance rule set. And you will now also resemble the ORT tools, because I think at least half of you put your hands up that you know ORT, so you will recognize those tools again. There's the analyzer, advisor, scanner, evaluator, and reporter. And we can configure here also in detail which of those tools we want to configure how. So for example, you see here the complete list of package managers that is supported by ORT. You can select which of those you want to run, and you can also further configure them. And it's the same for the other plugins. So Also, if you, let me collapse the analyzer again. If you want to run the advisor, for example, you also see a list of all the different advisors that ORT supports. So we have currently here Black Duck, if you are a customer of them, OSS index from Sonatype, OSV, and vulnerable code, where vulnerable code is itself an aggregator that gets vulnerabilities from a large variety of different sources. And the scanner then, of course, is running the license and copyright scan. Currently, we have just scan code integrated here at this step, or DOS, but that's currently an admin configuration, so users cannot choose. And Evaluator is our custom compliance rule engine from ORT. So that allows you to basically write any kind of compliance rule that works on all of the data that was collected previously. So you can write custom Kotlin script to basically implement all kinds of rules from certain licenses are not allowed to certain packages are forbidden or whatever you could imagine based on that data set. And the last step is a reporter. So ORT also has, like Sebastian said, a lot of different reporters that you can enable. And here, most importantly in the CRA context, is probably the Cyclone STX, Cyclone DX SBOM, and the SPDX SBOMs that we can generate. But we also have many, many others for integration with other systems. And maybe pretty important is also these template reports where you can also create custom templates based on, what was it, Apache FreeMarker template language. So you could also turn the data into any kind of PDF or textual report as you like. Okay, so once this fun run has finished, I also collect a lot of data, not just vulnerabilities, but I can see here, let me select the last run. So I get a list of projects that were found here. So in this case, there's just one Java project, a Maven project in this case, the same for J itself. And I can also get metadata that we could capture from it, which is quite a lot compared to other similar SCA tools. In addition to projects, I get the complete list of dependencies that was found. So these are all the different dependencies that we got. And Sema4j is a small library, so I only got some testing stuff. I got the SBOMs that I could download here, Cyclone DX in XML and JSON format, or SPDX in JSON or YAML format. And I also got the optional other reports. So maybe to show you also what that looks like for a bit larger project, could just quickly go through back to the first backstage org. Let's select here the ORT Server project. So here it becomes a bit more interesting because you see there now on this project we actually have over 1,000 different dependencies, 800 of them being Maven packages and about 250 of them being NPM packages. And therefore also you'll see a lot more vulnerabilities and that needs to be handled. Yeah. Did I forget to show something?
Not from my point of view, maybe just, we don't have too much time left, but one thing that I usually try to show, you need to help me with your touchpad, is the admin view of the plugins that we have. So just to give an idea of the number of integrations that we have in here. So this is the admin view of the plugins that are enabled in the instance. And they are grouped by type. And if we scroll down here, you see it's quite a lot, right? And these can be managed on an admin level so that you enable certain plugins for some of the organizations and for others not, and so on. So it has a quite sophisticated, template-based plugin preset mechanism, so to say. Yeah, back to the slides, I would say.
Yeah, we just got 5 minutes left.
Yep. Okay, what's up for the future? So maybe you recall one of the first slides said input is source code and then the magic happens and so on. One thing that we definitely want to do is to allow different kinds of input than the source code. For example, other SBOMs. So sometimes you get supplier provided SBOMs that you want to import, or you have, for some other reasons, existing SBOMs. And these usually do at least have enough information to check for vulnerabilities, for example. So this is something we're going to implement quite soon. And also, in general, we want to bring all ORT core or ORT CLI functionality to the UI to really make it fully accessible and on par feature-wise with the ORT command line tool. But we would still respect your existing, if you are an existing ORT user, configuration as code. So don't worry, there is a smooth migration path. You don't need to reconfigure everything and throw your YAML files away. They will continue to work, but going forward, you will be able to make, for example, issue and vulnerability resolutions via the UI. We will add release monitoring in the context of CRA. That's important because you need to somehow track what has been delivered and released and do vulnerability checkups for your releases, for example. And we also do want to cover other regulations than the CRA, thinking of DORA maybe and other stuff, including the paperwork. So while this is mostly not automatable, you probably want to have a holistic solution where you can track everything in one place, just putting some check marks on your to-do list, whether you fully comply or not. And one thing that we always do and aim for is to improve our integrations and also notifications that we have, so we can already notify via emails, via issue tracker integration and other stuff, but there will be coming more, right? Okay. That's it. So we have some minutes left for questions and answers.
Yeah, thanks a lot for your talk.
I was just about to say it's now 52 stars, but I was correct. It's now 53. Maybe.
Yeah. Keep up going, yeah please.
Good question.
Thanks for your talk. I have a question regarding some security-related metrics. Is it possible, for example, to get some metrics which I can show or analyze in Grafana dashboards and something else?
Technically, absolutely, I would say. So we're, as a community, also open for suggestions. If you have certain metrics in mind, this dashboard view that you saw, it's just in the making. It's stuff that we found useful, but we are also working together with Fraunhofer, for example, who have developed some metrics about software health. And we're totally open to suggestions. So if you feel that this or that metric would be useful, and please display it as a pie chart and not as a bar diagram, whatever, talk to us.
For example, this vulnerability diagram that you saw, that's bar chart, that's just an endpoint call to the REST API. So you could already fetch this with Prometheus, for example, and then show it in Grafana as well.
Yeah, that's a good point, by the way. So the UI does nothing which is not accessible via the REST API. So there is no logic or hidden features in the UI. Everything you see in the UI is fetchable or controllable via the REST API. So it's an API-first design, basically.
Another question. You already mentioned the policy as code. So is this still the concept for the ORT server? So ORT generally was very great in keeping track of things. So I have a traceability because every decision was a Git commit, for example. So if I now have a resolution and do this via the UI, does this still make a Git commit in the background? And is this traceable, or how is this handled with ORT server?
Do you want to answer, because you wrote the code?
It's not creating a Git commit in the background, because that's actually thought for the audience, which is not so technical. So I would say for developers, doing config as code should still be the way to go, because you can have the config directly associated with every commit in your repository. What we do is, of course, that we have an audit log for everything that's created on the server. So it will be recorded what resolution was applied, what was the reason, and who created the resolution. So it's not on the Git commit level, but at least the information will still be there.
And the data is not stored in Git anymore, but in a database. But the idea is the same. So if you created a server, a resolution from the server UI, then it will be applied to future runs on the repository, just as if it was committed to a .ort.yaml file in the repository. But no Git commits made in the background. Yeah.
Thanks a lot, guys.
Thank you.